Hey, I'm super excited to be here. Thank you all for joining us today. Really excited to show you what we've been working on over the past couple of years and where we've kind of taken the product. And hopefully give you a new option to look at when you're looking at getting started on AWS with a web application or maybe to simplify some of your operations. My name is Omar Lari. I am a principal product manager. I lead product for two products, for App Runner, which we're going to be talking about today, and for Beanstalk. So happy to take questions on either of those after the session today. And I'm joined by Miller Fanning today from Cox Auto. And so, agenda for today. This agenda has been pretty fluid. It used to be 1, 2, 3, go. It says 1, 2, go on there. It's really just going to be 1 go. I'm going to show you one easy way to get started on App Runner. The other way is even easier, so I think you guys will be able to figure it out when you try this on your own. I'm going to do a demo, and I'm going to ask the crowd whether they want to see a live demo or a recorded demo. So just hold that for a moment. There's this guy's going to cause me some trouble. I'm going to get to a point, and I'm going to ask the room, and whichever one gets more noise is what we'll do, either the live or the recorded. The recorded demo was done 2 months ago, and I know it works. The live one was finished about 45 minutes ago, so we'll see how that works out. Anyway, so we'll do a demo. What is App Runner, and why did we build it? And then Miller is going to show you how to really run these things into production after I show you some voodoo magic with the demo. So we'll get kind of real world use case for how to leverage App Runner in your own environments. So the next couple of slides I think have really kind of landed the time, like they've kind of lived through the test of time. And they're just pretty interesting. I've actually used these in previous slides that I've done at reInvent in the past. And this first one is kind of like, hey, you want to run containers, and you're like, where do you get started? There's all of these different options, right? You got this cephalopod out there in the water, throwing containers around, 2 turtles trying to talk to each other with microservices. What is service discovery? But you know you kind of want to use containers, but you're super confused about where to get started. And you're not alone. I had to kind of fuzz out the gentleman's name, but I think most of you know who he is. And this is just another one that's kind of standed that true test of time, right? It's like you're at KubeCon and there's all this confusion in the container space, and it still exists today, right? There's so many different options. It's like, do I use Fargate? Do I use EKS? All kinds of options just within the AWS ecosystem, and then even more as you kind of start looking outside. So we really wanted to make just a simple, dead simple way for you to get started. And maybe not even have to think about containers, and we'll kind of talk about that in some more detail. But if you're kind of accustomed to other container services, you know there's a lot of things that you have to stitch together, and we really wanted to make that easy for you. So with App Runner, which we're going to go into detail about today, is really providing you a set of best practices out of the box and guardrails to get you going. You're not having to manage EC2 instances. There's no clusters. There's no load balancers. Nothing that you really need to manage. All you see is an endpoint in your account once you supply either your container or your source code. Again, just with a lot of other AWS services, it's a consumption-based model, so it scales up and scales down. You pay for only what you use, but we've made that really dead simple. So you have auto-scaling right out of the box. You basically tell us how you want it to scale, and we take care of all of that for you. You're not having to configure any of that. And then, of course, it's integrated with the rest of the AWS ecosystem, and this is what customers really value, right, is being able to take advantage of things like RDS, things like Dynamo, and some of the other data stores, and ACM, and security tooling to really kind of grow your application. So access to all of that as well. So one of the things that we mentioned, is containers, your first container to the cloud, and kind of the confusion in the space. What I want to show you is a way to not even have to think about containers. You have an idea of an application that you want to build. You go into your IDE and your developer tools, check it into source code repository, and just launch it. So now is kind of the choice that we have here. Whereas our choose your own adventure story, or choose my own adventure story, I guess it would be, on whether you want me to do a live demo or a recording. So let's start with some noise for recording. Yeah, recording. Come on, recording. Okay, live demo. Oh, that was pretty weak. That was pretty weak. I'm going with the recording. I'm going to give you one more chance. Live demo. Okay. I'll take what I can get. Live demo it is. Can we see my laptop? Looks like it's trying. So while we're waiting for this, maybe I'll poll you guys with some questions. How many of you guys actually are familiar with App Runner? Okay, very few of you. Okay. How about any of the other AWS container services like ECS or EKS? Okay, a lot more familiarity with that. Okay, awesome. So I'm surprised you didn't not aware of App Runner, but a lot of influence was built. A lot of App Runner's influence was built from years of running those services, of running ECS and EKS, and getting a lot of just like customer feedback around, hey, we just want a really simple way of managing and maintaining our container environments. And so if you're familiar with ECS and EKS, you know they're very powerful tools, right? And they're very extensible. But it does require a fair amount of infrastructure knowledge, right? Like what are VPCs, what are subnets, how do you stitch these things together, IAM profiles, to try to get everything working in exactly the right way. And so with App Runner, we're, again, like I said, we run a lot of that stuff inside of our service account, so we're doing a lot of that heavy lifting of that operational overhead on your behalf. So it's not that that doesn't exist, it just exists inside of our service account, and we kind of abstract that away from you, and really just let you focus on the application. So I'm hoping that I get to show, because that was about as much filler material as I had for today.
Sorry, I'm trying to turn off the HTTP.
Maybe we'll come back to that. I'll cover some of these slides. I wanted to show these after we showed the demo part, but we can kind of go through the rest of this. So as I mentioned, a lot of these things are running inside of our service account, not your account. So again, if you've used ECS, EKS, Fargate, you see a lot of things, right? You see EC2 instances, load balancers, autoscalers, all of these inside of your account. With App Runner, we have 2 ways of getting started. The demo that I'm going to show you today is to actually build the application with App Runner. So we kind of manage a whole CI/CD process on your behalf. You basically tell us where your source code repository is, give us permission, and we'll build all of that on your behalf. So we have all of our CI/CD tooling, and then we deploy the application straight for you. And so we have a number of runtimes that are supported today, all of the popular ones like Python, Node.js, Java. I'm sure I'm missing a few of them, but they're all managed and maintained on your behalf. The second option that you have is to use just typical container tooling, right? So you're used to writing a Docker file, and you can just push that container image straight into ECR. And then from there, we'll deploy that on your behalf. So you have a level of control. So whether you can use our prepackaged runtimes and use that from source method, or you want to use your own tooling and just bring a container image for us. We deploy that application for you. As I mentioned, you'll see a URL in your account where you can access that application. That's automatically integrated with ACM, so we apply an SSL certificate to that. And then your clients can actually start hitting it, and it starts to serve requests. Again, as I mentioned, it's an elastic service, so you're only paying for when your instances are actually being used. The way that we do it in App Runner is that we scale on concurrent connections. So we have a concurrency threshold. And what's happening during that time when your container is processing requests is that you pay for both CPU and memory. And when it's not processing any requests, we actually throttle the CPU down and no longer charge you for that. There's a small provision memory cost that's associated with it just to keep that alive. And it also helps prevent cold start. So when your application needs to start processing requests again, that comes back up and you don't have some of the cold starts that you may experience with some of the other services. Again, not a whole lot that you have to do it in there. I'll show you this in the console. You basically set the number of connections that you want each application instance to serve. And then as soon as we start to approach that threshold, we'll automatically bring up a new instance for you. And you can set your min and max based on your application's profile. So some of the pricing dimensions, you pay for, as I mentioned, you pay for compute and memory when your application is serving traffic. When it's not, you're paying only for the memory hours. So this is the pricing. So 64 hundredths of a cent vCPU hour, 7/10 of a cent for the gigabyte hour. If you use the from source method, there's also an option to trigger automatic deployments on every push to your source code repository. So every time you do a git push, will actually automatically deploy that for you. And then there's a $1 per month fee that's associated with that. And then you pay for the build time as part of that as well. So the CI/CD tooling that we have to build and package your application is also priced. So it's pretty straightforward pricing for, these are some different types of scenarios that you may have as you're kind of working through. As you start to scale, your application, when you start off, you may only have a single instance that's not, serving traffic all of the time. Oh, I lost my slide here. And then obviously as you start to scale your application, the costs kind of go ahead and start to increase with that. So just wanted to provide you with a couple different scenarios here on the cost of what that would look like. But this is really great if you're, but not only just starting off and you want to test an application and get going, but even as you start to scale, you'll see that these costs are pretty nominal for even a high volume production app. So I'm hoping that we have some luck here with the demo laptop. Well, this is fun. Thanks. I was nervous about my demo not working, but not my laptop not working. I'm losing a few folks. Sorry, guys.
Can your source code be anywhere, or does it have to be within AWS?
That's a good question. The question was, can the source code be anywhere? Today, the source code repository that we support is GitHub. So we're looking at supporting additional repositories, but that can be in GitHub today. Yep.
What's the roadmap look like for GitLab?
Yeah, so that's a great question. Actually, we might as well do Q&A while we wait for this. So the question was, what was the roadmap? What does the roadmap look like for other source code repositories? So yeah, GitLab is definitely one that we're looking at. Bitbucket, we have our own code commit as well. My last slide has a link to our public roadmap where we can actually upvote. So that's one of our sources of information that we synthesize across other kind of inputs to look at, which ones to prioritize. Any other questions while we're here?
Yeah, and does App Runner run as the CI/CD pipeline basically? Does it seem like it also contain orchestration, or does it actually support when you have to build and deploy through App Runner?
Yeah, so I think the question is, do we support like full CI/CD or? Yeah, so we have customers using it in a couple ways. One is, oh, there we go. Okay. Now it's my turn. I can't blame anybody else anymore. Okay, so what I'm going to demo today, and hopefully this all works, is we're going to deploy an endpoint inside of App Runner. So first, what I was talking about is like, hey, you kind of have an idea. You want to build an application and get going. So I have this small front end that I hosted, and so I thought it'd be a cool idea to say, hey, let's map out all of the different hotels and locations that reInvent is being hosted in this year. And so this is a real simple application, a static front end, doesn't have any dynamic back end to it. And so the only hotel I have mapped is Mandalay Bay. And so say that we want to add some kind of dynamic content to this and map out the rest of them. You typically do this with a database and stuff, but I'm going to kind of cheat with just a Flask app. So bear with me one second. What I'm going to do real quick is I'm going to do a live demo, but I'm just going to run through this real fast, and then I'll come back and walk you through it because I want this to be finished by the time I'm done. So this also kind of just shows you how quickly you can get going as well. We have a couple of workshops that will walk you through this. So you will be just as much as an expert as I am. So this is part of the live demo part. Vegas demo. Okay, so let's hope that worked. In parallel, let's actually walk through. Oh, it didn't work. Oh, I already have a Vegas demo. Thank you for catching that. Something very original, Vegas demo 2. Okay. Thank you for that. That would have been a disaster to come back and just see that. But let's create one from scratch because I kind of want to show you what this looks like. What did I actually do? I have a backup here in case this doesn't work. So when you go to create a service, like I mentioned, you can start from two different places. One is container registry. Today we support ECR. Again, we're looking at additional repositories for both source code and container images. For this demo, what I selected was source code repository. I have an app in GitHub. It's a basic Flask app. And basically what that app is doing, I'm going to show you here. Does anybody know how I can zoom in on this for you guys? Is it Shift plus? Command Shift plus. There we go. Thank you. So basically that front-end app was just pulling a static page that was in there. I just created this Flask app where I'm JSONifying all the coordinates of the hotels where reInvent is being hosted. This is just GeoJSON format that Mapbox understands. I have this in my front-end JavaScript code. So real simple, nothing fancy. Generally what you would do is store this in an RDS database, but that's for the deep dive sessions. Go to the workshops, check that out. They'll show you how to do that. But for the purposes of this, we just want to get a live endpoint that we can hit. And then I'll go back into the JavaScript code and we'll provide it that endpoint, and hopefully it'll illuminate with all of the locations. This app is actually publicly available, so follow along on the adventure if you'd like to. It's map.omarlari.com. And we'll kind of, hopefully, in a few minutes, we'll see all of the places light up here. So anyways, I connected to GitHub. I'm connecting to that Vegas demo application. I'm giving it some information on where the repo is, which branch I want. I talked about manual or automatic deployments. In this case, I'm just going to do manual to keep it simple. But if you wanted to refresh every time you do a Git push, you can do that as well. Couple things in here is the configuration file section is that what we're going to do is we're going to walk through all of these because I want you to see all of the different settings. But you can also provide a YAML file and actually submit that in your source code, and it'll pull all of that away. So things like runtime, scaling mechanisms, environment variables, all of that kind of stuff can be defined in a YAML file and submitted to source code repository as well. But for today, let's kind of walk through all of that. It's a Flask app, so I selected Python. You saw me do this real quick, and hopefully I didn't do any typos on it, but I'm just using the requirements.txt file, and I am using Green Unicorn to proxy my app. And I think I'm hoping I went and changed it to 5,000, because that's what my app is listening on. I think I did. So in the next screen, we're going to configure the service. So each app runner kind of boundary line is this service encapsulation, which defines all of the metadata that's associated with this service. So again, there's nothing really confusing here. We'll just call this Flask demo since I already used Vegas demo twice. You have a couple options on t-shirt sizes for how big you want your application instances to be. I didn't do any application profiling on mine, so when we look at the metrics, you're going to see a bunch of 500 errors and other problems that were done with it. But it's good for experimentation to kind of see those problems. But you'll want to kind of profile your application to understand how many connections a typical application instance can handle. So anyways, we have 4 different t-shirt sizes. You can do 1 vCPU with 2, 3, 4 gigs of RAM, or 2 vCPUs, and that comes with 4 gigs of RAM. Any environment variables that you want to provide as well. So the way we're seeing customers use environment variables today could be for secrets. We have some work coming on with secrets integration as well, secrets manager integration. But if you have any other kind of environment-specific variables, those can be provided here. I talked earlier about how we scale in the concurrency model, so you can define that here. Again, the defaults work well for this demo. But you may want to say like, hey, this 1 vCPU, 2 gig RAM CPU instance can only handle 25 requests. So you could go ahead and configure that however you want to. You can also set the minimum and maximum number of actual application instances. This translates to a container in the backend. That's really an implementation detail. But that's kind of the service level encapsulation and where the pricing dimensions come into place. So for each application instance that's active, you'd be paying for that while it's accepting connections. Nothing super special here. We're just performing health checks. So you can define timeout, the intervals, all this kind of metadata on how you want your health checking to perform here. For security, we just provide some out-of-the-box roles that allow us to run the service. You can also provide your own IAM role. So if you're connecting to like a Dynamo database or an RDS database, S3 bucket, you can make sure it has the correct IAM permissions and attach that to the service, and it'll inherit those permissions. We also use a KMS key to encrypt your source code or your container image. So anytime we're connecting to GitHub and downloading your code, or we have access to your container images, those are self-encrypted with our own self-managed KMS key. You could also bring your own KMS key too if you have kind of security requirements on using your own key. We have a couple different networking modes as well. If you've been following App Runner for a while, you know we didn't have VPC support. This year we've introduced support for both VPC ingress and egress. So what that allows you to do, egress allows your App Runner services to connect to services inside of your VPC. So I keep using the RDS example, it's just a common one. But if you have a container that needs to access databases inside of your VPC, you would use the outgoing network traffic. The incoming network traffic, previously, again, App Runner service URLs were only available publicly. We now have an option to publish that inside of your VPC. So if you have private services, internal websites, things that you don't want published outside to the world, those can be restricted to be accessed only within your own networks. We have a lot of out-of-the-box telemetry and observability capabilities with CloudWatch for logs and metrics. I'll show you the console here shortly as well. But we also have integration with X-Ray as well. So if you want to have some tracing data out-of-the-box X-Ray, all you need to do is turn this on. I'm not going to turn this on again. I just want to kind of show you so you can see what's going on here. Tags, again, you're pretty familiar with tags if you're in the AWS ecosystem, but this is just a way to apply metadata. One of the particular things that I like about tags here and App Runner and how that works out well is that you can actually see at a very granular level how much each of your applications is costing at the service level. There's no additional things to tag, right? You're not having to tag EC2 instances or load balancers, any of those other components. You just tag the service, and you can see exactly how much that is costing you through Cost Explorer without having to tag all your different environments. And that's it, review and create. And so let's go back and see how this is doing. Oh my goodness, that worked. Okay. Okay, so this is the API endpoint that it deployed for me. So we'll go back into the JavaScript code and replace the path that it's pointing to with this, and then hopefully we will see all of these light up. So again, this is the app, and you can open this on your phone. Actually, please do open it on your phone because it might show some traffic for us as well. And you can also see that I'm not trying to trick you. Okay, so what I did here is basically it's fetching the data just from a local file system. What I'm going to do now is actually fetch it from our API endpoint. Make sure this all looks good. Okay. So look at your phones. This is pretty quick. This is the static site. Not yet. No, yeah, this is a not hosted on, this is just a front-end static site on S3. Not, yeah, someone caught that, very good. It's map.omarlari.com. There we go. Woo, it worked. So real simple, right? That was pretty fast. We didn't set up any EC2 instances, no clusters, nothing to manage. I've got an API endpoint, and that will start to take traffic. So I was throwing synthetic load at another one. One other thing I want to show you before I hand it to Miller, who's being super patient with me here today, is my original Vegas demo. So you'll see all the event logs as we kind of build your source code and deploy to container images. So you'll see event logs, your deployment logs. These are also actually accessible to you within CloudWatch as well, but we just provide those to you in the console. So from CloudWatch, you can obviously take those into any other tools that you're using. So all of the deployment and application logs, I was not a good developer, so I didn't actually do anything to standard out, so there won't be anything in there. You can also see any of the service encapsulation activity, but this is the one that's probably most useful, as you can see. And this is not the load of this service. I've been throwing load at, just synthetic load at this, just so you can kind of see. You can see the request counts, how many HTTP 200, 400, 500s we're getting, request latency, and then how many active instances are being used to actually power the service. So again, real insightful information for you to be able to see what's going on. All of your other metadata here as well. I won't go through this again, but all the configuration that we looked at. One thing I did want to mention as well is you can actually do custom domains in here as well. So right now I've got this ugly kind of self-generated URL. You can actually add your own custom domain in here as well. So I could do like mapbackend.omarlari.com. And basically what this has you do is just add some CNAME records into your hosted zone file, and then it reconciles it just to make sure that you own that hosted zone. So yeah, so with that, I'm going to hand it off to Miller because I took way more time than I was supposed to, and hopefully we have some time for some Q&A here at the end. But hopefully that was useful, and this is a new service you guys can look at when you're looking for a way to deploy containers.
All right, well, I do not have a live demo today, so I want to apologize for that. I wasn't the brave one, so thank you, Omar, for leading the charge for us. Well, good afternoon, everyone. So my name is Miller Fanning. I am a principal software engineer at Cox Automotive, and I am here today to talk to you about my group's journey on serving containers in the cloud and how we have evolved existing patterns from the known ECS over to App Runner, and then to give you a little bit of insight into some of the processes and some of the best practices that we use to help make sense of all the craziness in the container world. And then we'll cap it off with how you can take some of your existing container applications and really productionalize them and get them ready for all of your major use cases. But before we dive into all that, I think it's good to get a little bit of background, and I will do my best to keep this super quick. I'm assuming that a lot of you out there recognize at least two of the brands that are up on that slide, and I'm assuming that would be AutoTrader and KBB. But Cox Automotive is about 25 additional auto businesses in the auto industry outside of just what you see on the screen. We do everything from wholesale vehicle auctions at Manheim to the software that runs in your local service repair shop, all the way down to EV battery recycling. So all of these brands do all of these services, which generates just an enormous amount of data. And all of that data needs to live somewhere. Well, that's where my organization comes in. So my group resides within the Cox Automotive Enterprise Data. And then my team in particular is the MLOps Platform Engineering. But what does that mean? So our goal is to do for data science what DevOps did for software development. And what that means for us is that we want to build a platform that allows our data scientists to take their code from development to production without the need for engineering to get involved and handhold the entire way through. And in order to do this, there's a lot of little things that we as the platform engineering need to provide to our data scientists. We need to ensure that all of the different packages and services that they use on a day-to-day basis can be configured properly. We know that there's lots of different run times. There's lots of different operating systems that have to be used. And we need to ensure that we can provide those to our data scientists, while still maintaining control over what is actually happening in the day-to-day operations. We also want to do things like standardized logging. We want to ensure that the logs are actually coming down. We want to have standardized metrics. We want to have a single pane of glass into all of the different services that we deploy. So how do we do this? Well, to provide a platform like this and to be able to provide the tools for our data scientists to deploy their APIs, containers are a really good use case, right? Containers give us a whole lot of flexibility. But where do you start? Right? I know we polled the audience earlier, so that worked out well. That I know there's a lot of familiarity with containers and running on ECS on Fargate and some of the other AWS tools, but it's still kind of hard to narrow it down sometimes, right? Should we roll out a whole Kubernetes cluster for a single application? How do we go and configure Fargate to do what we want to do? Well, one of the architectural principles that we take at Cox Automotive is that we always want to start with the most serverless option, and then we gradually peel back the layers of abstraction until we get to a place where we're super comfortable with managing these different services. So we're going to take ourselves back about 2 years ago, before App Runner was officially GA, so we're going to hide that option. And for us, AWS Fargate was the right option that gave my platform team the ability to configure and run the different data science models while still being able to be somewhat serverless without the need to watch and manage services day to day. And what did that give us? Well, they gave us the known ECS pattern. And there's a lot of you out there that I'm sure run Fargate applications and have dealt with some of the complexities that come when you decide to run with Fargate. But with those complexities also comes the ability to do really fine-grained control and do a lot of application tuning at every single stage of the process. Well, this diagram in particular has a lot of moving pieces that you have to go and configure. And what this diagram gives us is essentially the demo that Omar just did. So if you are just a smaller team or you're an operations team, you now have to have somewhat intricate knowledge of networking, of how ECS scales, your task definitions, service definitions, how does auto-scaling work, and how you can build your auto-scaling policies to give you exactly what you just saw in the demo. And that can be tricky, right? There's lots of things that can happen. But this worked for us. And this was a great pattern for us to use because everything up there is serverless. Everything up there allows us to configure it, do some monitoring to make sure everything's working as expected, and then sort of have me and my ops team sit back, have a little bit of a vacation, take a breather, and that was great. But there's always an until. Right? There's always the use case that creeps up and sneaks up on you. And for us, that use case was one of our data science teams wished to integrate onto the platform, and they came to us with some interesting use cases. The first requirement was that we needed to support the R programming language, which is fine. Right? With containers, we have the ability to configure the base images, configure the all the different components as we need, and so that was fine. Cool, box checked. And then they said they had a very unique traffic pattern. And for us, that's always a very scary sentence to read in the message because it's not a predictable, it's not an easy, it was unique. And what their traffic pattern happened to be was they were doing some stream processing, and it would go from 1 to 200 predictions a second up to 3 to 4,000, nearly instantaneously. And this becomes a major problem when it comes to auto-scaling, especially with data science, because a lot of the data science tools and technologies take a while to spin up. Right? There are cases where it can be 1 to 2 minutes before containers can ever be ready to serve traffic. So if you know that you maybe have a 2-minute cold start that you're guaranteed to have, and you're at the 3 to 4,000 requests a second, that's a lot of drop traffic if you just get these huge spikes. But it's actually a fairly simple solution using this known pattern, and you just way over provision your ECS clusters. So what we essentially had to do and what we accepted from a cost perspective is that we were going to need to run these model APIs at true spike strength 24/7, 365 in order to ensure that the SLAs would be met from our downstream teams. Which, from an ops perspective, is fine. There might be some Cox Automotive people here in charge of the budget. They might not have been as thrilled about that solution, but we knew that we could do it. But can we do better? Well, around this time that this use case came to us, we were sort of poked and moved by some internal teams to say, hey, go check out App Runner. And just reading through that initial the initial requirements and the initial cost benefits, we realized that we could have the exact same over-provisioning without paying for all that wasted compute. So we spend maybe a couple $100s on memory, and we knew that when those traffic spikes happened, our containers were warm, and we could appropriately serve the traffic back. And so what we ended up being able to do was migrate into the App Runner pattern. And I personally find this diagram really funny because it really simplifies and it shows the contrast between what was and what is. And as Omar showed and Omar demoed, that all of the complexities from your service discovery to your VPC networking to your auto scaling to all of the configurations that we used to have to manage, now abstract away over to App Runner. And this worked. And what was really cool is we were able to then take a step back and look at the other models that we had deployed, and we realized that everything started to fit really well into this App Runner pattern. So it became just another tool in our tool belt that we knew that we could leverage. So we always wanted to start with App Runner, and then from there, peel back your layers of abstraction. And there were some additional benefits outside of just some of the performance. Yes, the burst traffic was great, but we were also able to make the development experience better for our data scientists. We were able to take our lower environments and have them more closely mirrored to production because we could keep them over provision without really worrying about the cost. We were able to do things like multi-region deployments. Lots of brands on that initial slide, there are companies all across the country. So in order to give those companies and those service teams a lot better experience, we could do those multi-region deployments. And it's also a good test to see, does my service deploy in all the regions that I expect it to? And this was great. And this really, really worked for us. But this is also about your first container. And in both of those diagrams that we just saw, there was a key piece in there that kind of brings it all together if you need to build your own service. And that's ECR. You need to get your code into a container to get it to the cloud. But how do you do that? I know I personally, I come from a Lambda background. I've done a lot of serverless work. And so moving into the container space was always somewhat daunting because you just never really know what the right way is, right? How do I get there? How do I build? How do I bundle? So the approaches that we take are we start in Git, right? So we make sure our data scientists are doing all their work in our version control. They create their PR against their repository, and that kicks off our build process. So what we're able to do is we're able to essentially scan the code that they are writing. We're able to make some logical determinations around, oh, you're using TensorFlow, or it's an R model. We can pull the right base image, make sure that the packages are configured correctly, and then we can also help their build times, right? They're not having to build TensorFlow from source. They're not having to do all this R downloads, which takes forever. If you've never experienced it, I am jealous. But this pattern allows us a very consistent way for data scientists to package their code together and take it into ECR, which will eventually take it into production. And we're there. We have our container. We've built and bundled our container, and now we need to do something with it. So this is the high-level flow that we use in order to move a single container through our different environments. So starting from the top, we can see that we have this pre-UAT environment that allows our data scientists to do rapid integration. We're not having to do a lot of cost optimization. We're not building lots of monitoring tools because we know that even if one of our data scientists over-provisions one of their services, we will be okay and we can sort of see that, leveraging tagging, in sort of the budgetary items as they come through. From there, the PR gets the normal PR approval process. We go to our UAT environment, and now we can start to have manual interaction. Our downstream service teams can do load testing against new model versions. They can interact with what is a true production scaled model without the need of engineering to be involved. And then production is production, right? We want code to go. We want rapid iteration. We want to do small version changes. We don't want to have a 2-year lead time, especially in the auto industry. If anyone has realized about some of the car prices, right? Things are changing fairly rapidly, and we want to make sure that we're giving everyone the most accurate prices and the most accurate descriptions that we can. And then a really important call out is that it's the same image that's deployed across every environment. There's no rebuilding. We're not restarting per stage. We want to take the exact same container image, that is going to be in production and run that in pre-UAT, because we know that at every single step of our process, you, our consumers, are interacting with the exact, essentially the exact expected code once we go to prod. So then you're in production. We've taken this container, we've put it in App Runner, we've deployed it. We saw with Omar that we had that sort of GUID-ish URL. But now we need to do more, right? Now it's time to truly productionalize our service. So one of the tools that we leverage is API Gateway. So we've been able to decouple our auth and leverage multi-region routing with a lot of the baked-in tools of API Gateway. And since App Runner provides us that out-of-the-box HTTP URL, we can integrate it seamlessly with API Gateway. And this decoupling of the auth is really important because it allows us to understand that when we build and bundle a container for data science, it is truly just data science code that's running in those containers. Because if we had to push an update to those authorizers or some sort of additional request metadata, what we don't want to do is have to roll out an entire suite of new model versions, because then things just get complicated. So by doing this decoupling and leveraging the existing capabilities of other AWS services, we can really focus on serving our data science models as best as possible. So then from there, we need to extract data. We want to make sure that as requests are flowing in, we are able to capture our logs and capture our metrics and get them over to our reporting tools. New Relic is one of our providers that allows us to build that single pane of glass to where we can have multiple services streaming all of the data in. It allows our stakeholders to not have to go poking around in our Amazon accounts, which is something that we're all very thankful for. But this could be anything, right? App Runner is a core component of what we deploy, but it's also very easily integratable with other AWS services and very easy to take your existing tooling and integrate with. And there's always room for improvements, though, right? App Runner is a brand new service, right? There are things that if you do decide to migrate on App Runner with, it's not all roses, right? We do have to have a couple thorns have to be there, but the goal of all of this is to provide some feedback and make sure that we're helping push App Runner in the right direction. And some of the things that you might run into is that while CloudFormation support does exist for App Runner, there are some configurations that you might want to do that are going to require you to make some CLI calls in your CI/CD processes. You saw with Omar that your options are 2 CPUs and 4 gigs of RAM, or 1 to 2 CPUs, 2 to 4 gigs of RAM. Well, not all workloads fit into that, right? A lot of our deep learning models don't necessarily fit really well with 2 gigs. We need more. It just doesn't work out today. So there are times where we want to use App Runner, but we know that our fallback with ECS Fargate is an existing pattern that works. And then there is some optimization around cost that with App Runner, if you have very, very, very high and very sustained traffic, you could potentially see your cost be higher than if you're running on Fargate. But that's just a line item, right? The time that your developers save with going to App Runner, the time that we've seen that we've been able to build services that help our data scientists and help push the business forward far outweighs the potential cost that we see if any of the APIs happen to start to break even with Fargate. So from the opportunities of improvement, I think now it's time to pivot back to Omar and give us a little bit of idea of what the roadmap looks like.
Yeah, thanks, Miller.
Thank you.
Miller wanted to cut the opportunities for improvement slide out, and I said not to. I think it's good to be transparent. And I spend an hour on the phone with Miller every week where he tells me all these things that he wants me to do. So we welcome the feedback. We want to improve the service. We want to make it usable for your use cases and your workloads. And I think it's super important that we have partners such as Miller, the rest of you. We'd love to have you use App Runner. I just wanted to show this slide as kind of a highlight of the activity that our engineering team has done. They've really delivered a lot with a pretty lean team. As I mentioned, I won't read all of these things off, but a lot of the VPC configuration, new runtimes, cross-region ECR capabilities, and we're not stopping. We've got a ton of stuff coming next year. So again, please look at the App Runner roadmap on GitHub, upvote the things that you want to, talk to your account teams, your SAs, your account managers, get me on a call with you every week. I'm happy to hop on a call and talk you through this, help you with your applications. We've got a whole team of SAs, and we've got product folks, engineering folks that would love to talk to you. I would love for you to actually build something, tweet me, CC me on a tweet, show me what you've built, ask me for help. I'm always available. My Twitter DMs will be open here. I'll share my handle here shortly. Couple other just quick housekeeping things. We'll take some questions. We've got a few other sessions here as well, so I'd love to have you guys check these out. We have a deep dive, so we have the 300-400 level sessions coming up. So yeah, take a picture of these, check these out. The last one is actually a workshop, so you will actually be able to deploy an application yourself. Actually, both the CON207 and 408 are both workshops, so if you have an opportunity to register for those, get in there. They'll walk you through a similar demo as mine, get this working in your account. Like I said, feel free to DM me on Twitter, and I will definitely respond to you and reach out to you. Happy to hop on calls and engage with you. So you have my information there, and thanks for bearing with me with a little bit of hiccups. We made it through there. Luckily, I had a little bit of filler time in there, but I appreciate you all staying here, and thank you very much. We'll take some questions.